Good morning, everybody. So today we're going to continue working with inequalities. We're going to wrap up this week. We're going to do two-step equations now, just for more practice with them, and also working on the small differences there are with inequalities. So let's take a look at this first example I have up here on the screen. And I guess before I get into it, just a reminder, we do have a test. Our final exam is on June 12th. That is next Friday. So you're going to want to make sure you've done all the IXLs and all that. Make sure you're ready. I'll also be posting a study guide or two next week. It will be a smaller test, so probably just one, but we'll see. So let's get into this question here. We have negative 4 plus 3u is greater than or equal to 2. So remember what the goal always is. Even with inequalities, we still want to get the variable all by itself. And there's going to be two things we need to keep in mind. Remember, the order we pick to do things when we're solving equations is easiest if we follow PEMDAS backwards. So normally it goes, please excuse my dear Aunt Sally. That's the normal order of operations, but we're doing it backwards since we're kind of unwrapping this variable, unwrapping it out of the package. So if you're not sure where to start, that's what you should be referencing. Now, again, we start off with addition and subtraction. We need to look at our equation here. Are we adding or subtracting anything? Think about it. Okay, you should have said, all right, well, we have this negative 4 here, right, that we're adding. We're adding it to 3 times u. Right, remember, this is always, we don't write it in there, but this is multiplication. So multiplication comes next, but we're not there yet. So we have to deal with this first. So we have to think about what do we need to do to get rid of this minus 4? Well, what if you add positive 4? Well, then these cancel out because we know negative 4 plus 4, they're opposites, so together they're equal to 0. Right? Just like negative 1 plus 1 is 0. Negative 12, doesn't matter. Anytime you pick the opposite number, it's equal to 0. So we can do the same thing here, but we have to do the same thing to the left side. Right? We added 4 to get rid of this 4, this negative 4, so we have to add 4 over here. So this gives us 3 times u on the left side. This went away. And we know this is greater than or equal to 2 plus 4, 6. So from here, you just need to get the variable by itself. So we need to divide this 3 away. Right, we know 3 divided by 3 is 1. So these cancel out. But we have to do the same thing to the right side. Just like with normal equations. And so if you're not sure what I'm doing, make sure you're looking at last week's IXL and videos, because we worked on two-step equations all last week. That's what this is. We're going to see a couple differences, but it's very, very similar. So in the end, we get u is not actually equal, it's greater than or equal to 2. So we got our variable all by itself. So now the final step here is to plot it. So we know that u is greater than or equal to 2. So we have the bar here, so we need to do a solid dot. We're going to put it on 2. and then we need to decide what direction it should go. So we know u is greater than 2, greater than or equal to 2. So I'm just going to write that right here. And let's just try out a point from each side of this. So let's try out, okay, if u is 0 or if u is 4. So 0, we have 0 greater than 2, greater than or equal to 2. That doesn't work, right? 0's not bigger than 2. You guys know that? So that can't be it. So that must mean that over here on the right, we should see that this should work. 4 greater than or equal to 2. This works. So what this means is everything to the right side of this dot here is going to work. So that's the way our arrow is going to go. So if you're not sure how to decide which way the arrow should go, try plugging in a point from each side of the dot. In one of the extra videos I posted yesterday, he goes through this pretty well. So goes through it quickly too. So if you want to see a little more about that, I suggest watching that video. So let's go ahead and plot this. Right, solid dot. Then we know it needs to go this direction. There we go. Alright, let's take a look. I'm going to skip this one. Let's do this. Alright, so again, we're treating this like a normal equation. And we know that our variable is q. And we know that we want that all by itself. So again, we think of PEMDAS, and then we're going to think about it in reverse, backwards. So let's put the arrow this way so we know that. So we need to do addition and subtraction first. Well, we're subtracting 1, but we're dividing by 2 over here, so addition subtraction comes first, and then we'll divide by the 2. Okay, so this comes second. So to get rid of this 1 over here, well, what we can do is add 1, because we know minus 1 plus 1, well, together those would be 0. So those go away. And then on the left side we add 1. So this gives us 1 plus 1, 2 on the left side. And now we have q over 2 is equal to 2. So we want to get rid of this 2 down here in the denominator. Well, we're dividing by 2, right? So since we're dividing by 2, right, this bar is division, we can multiply by 2 to undo it, to cancel it out. So these cancel out, but we have to do the same thing to the left side. On the left side, we have 2 times 2, which is 4. So 4 is less than, well, the 2's canceled out, so 4 is just less than q. And now we just need to graph it. So let's look for, let's see, 4. And then we need an open circle, right? There's no line here, so we need an open circle, like that. And now we need to think about which direction it should go. So let's see, let's try, it doesn't matter which point we pick, but 0 is usually easy to work with. And then let's try 5. So let's see, is 4 less than 0? And we're plugging in 0 for q. 4 is not less than 0. So that won't work. Let's try the right side. 4. Well, let's plug in 5 for q. Let's test this point out. 5 is bigger than 4, so that works. So that means we need to graph the line in this direction. Because everything over here, if 5 works, that means everything else will work. Every number bigger will also work. So this line shows us all the solutions that'll solve this inequality here. So we put it at 4, an open circle, and we want this direction. Okay. We'll just do this one. Get a lot of examples in. So again, b over 2 plus 1. I'm going to go through it a little bit quicker. Remember, we think of PEMDAS backwards. So we're going to start off with addition and subtraction. We're going to get rid of that first. Then we'll get rid of this 2. And we want to get our variable, v, all alone. So to get rid of this 1 over here, we can subtract 1 away. These cancel out. These cancel out. But then we have to do the same thing to the right side. So this leaves us with just b over 2 on the left. On the right side, we have negative 1 minus 1. It's negative 2. So now we need to get rid of this 2 in the denominator. So we multiply both sides by 2. So these will cancel out because 2 divided by 2 is 1. And this will leave us with, let's see, we have just v is equal to, or not equal, but less than, negative 2 times 2, negative 4. And we got our variable all alone, so that means that we solved it. Now we just need to graph it. So we have negative 4, and we need an open circle because there's no line. So we leave this open. Now let's decide which way it should go. Let's see, let's try 0. Let's try negative 5. Okay, so let's try, so we're trying out 0. So we're going to plug in 0 less than negative 5. So that's what we're checking here. That didn't work. So that's wrong. Let's try out negative 5. Sorry. This should have been, it doesn't change anything, but it should have been negative 4. But it still doesn't work. Now we're going to try out negative 5 over here. So negative 5, let's see, is that less than negative 4? Yeah, negative 5 is less than negative 4. So that works. So what we did is we tried out 2 different points from both sides of our dot here. We tried out 0. We said that didn't work. So that means everything over here won't work. But negative 5 did work. So that means everything to the left side of this dot will be a solution. Every number to this left side will solve the inequality. Alright, so we have negative 4, open dot, should go in this direction. Alright, so again, these are really the same type of problems. The only thing is, just remember I made a little note, where if you have a situation like this, like if you had negative 2x is equal or greater than 4. So with inequalities, really the only difference from normal equations, besides how you graph them, is if you divide by a negative number or multiply both sides by a negative number, you have to flip the inequality because of it. We have to flip it. We have to flip it because we have this negative here and negative here. So that's why we have to flip it. So we flip it around, so we'll put the mouth open that way. And then on the right side, just 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is just x. So that's really the only difference with inequalities, if you see a question like that. But everything else is the same as you did with two-step equations and what you were doing earlier this week with just graphing one step and just normal inequalities. So that's all I have for you guys. Hopefully you're finding this helpful. If you have questions about this assignment, please let me know. If you need to schedule a live session or anything like that, you can always do that. I'm willing to make time when I'm available. But also we do have our live stream on Friday at 11 o'clock like usual. So if you are having a hard time in the IXL, the work this week, you really need to be there. Really, even if you didn't, you should still be there because you can ask questions about the class, or you can just hear me talking about the work will make it make more sense. And sometimes maybe there's an extra topic I like to build on too. So it is really important you're coming to the live streams as much as watching these videos. So thank you. Please take care, everybody, and have a good rest of your day.